Hello, and welcome to today's webinar, Control Charts and Next Generation Statistical Process Control. My name is Andrea Gergich, and I'm a Marketing Content Manager here at Minitab. A few quick notes before we begin the webinar. We'll have a Q&A session after this presentation, so please submit any questions you have, and we'll do our best to answer them. If we run up to the end, unanswered questions will be addressed afterwards via email. We recommend viewing this webinar via laptop or PC for best results. If you experience a delay or sync issues with the audio and slides, please exit the webinar and rejoin. We will be sending a copy of the recording following the webinar, so there's no problem if you miss anything or you'd like to review afterwards. Now, it is my pleasure to introduce our presenter today, Jenn Atlas. Jenn Atlas is a Global Market Development Manager here at Minitab. Jenn studies how organizations solve analytical problems to ensure that Minitab keeps delivering on our commitment to make data analysis easier. As a classically trained statistician, Jenn has worked, trained, and consulted in the field of analytics for over 25 years. Now, I'll hand it over to Jenn to begin today's presentation.
Thanks, Andrea. Welcome, everyone. Thank you for taking the time today. So what I'd like to do today is we're going to talk about control charts and statistical process control. And I thought what would be interesting is that when we talk about statistical process control and real-time SPC, I think that also opens up the door for control charts in general, in terms of, we see control charts being one of the most popular tools of the quality practitioner, but also we're seeing it being used by many other people nowadays. So I thought we'd start by talking about the different ways that we do see control charts in use throughout different job roles. So first, as a data exploration and monitoring tool. We'll also talk about the use of control charts within dashboards. These could be business dashboards. They don't have to be a manufacturing setting. And of course, within the real-time SPC context, and we'll take a look at that, where we're using those control charts really to monitor the quality of our process and allowing us to react in a very quick way. Then we'll talk about what we call the next generation real-time SPC. So really adding other tools that we use in our toolkit to help us make real-time SPC even more powerful and more effective. So let me start with just a discussion of what control charts are. So if you're new to control charts, don't worry, control charts are really just plots, time series plots that have some extra elements about them. So the important part to understand is that plotting the data in a time-ordered sequence is usually required, because if you want to understand how the behavior of a process, it's important to keep your data like that. Now, all control charts have certain elements. One thing is a center line. And this is usually the average, depending on what kind of control chart you're looking at, basically looking at the most common value. They also have what's called an upper control limit and a lower control limit. Now, these control limits are based on what's reasonable to observe based on the data that you have. And really the benefit of control charts is really understanding when a process is acting in a way that's I would say the variation is normal in terms of what you'd see. And when I say normal, I don't mean normal distribution, normal, for those of you with stats backgrounds. I mean just the variation that we tend to see from day to day over the course of a process. And what these lines represent is there's some statistical background behind it. But what's important to understand from a practical standpoint is that this is the variation that I would expect to see within a process just that's behaving as it just stable over time. When we start to see some patterns or some values outside these ranges, that's going to be an indication to us that something is going on, something's affecting that process. Now, before we get into more details about the control charts, let's just talk about why people use control charts and why you might consider using them if you don't already. The main reason, determining whether a process is stable and consistent over time. If I'm making product, if I'm placing orders for delivery, whatever processes I'm doing, I'd like to know that I'm dealing with a stable process. A stable process is one that behaves consistently over time, means that I can reliably count on it to deliver my product or service. Another use is the assessing how effective a process changes. If I'm working on a process and I want to improve the process. So I guess I should back up by saying a stable control chart doesn't mean it's a good process. It just means it's consistent. So it could be consistently bad in terms of how you're delivering your, whatever service you're delivering. But knowing that is important, but then we go ahead and make some changes to a process, we make some improvements. It's important to be able to demonstrate that improvement. Control charts are very nice to be able to track that, but also communicate that with our coworkers or team. Said communicating the performance of a process during a specific period of time. If you work within supply chain, it's important to demonstrate that you can behave consistently, that your process is behaving in a way over a certain time period that is consistent, and that's important. And also for those of you who calculate capability, which is probably most of you if you're using control charts. So while control charts just tell you if a process is stable over time, it doesn't tell you how well it's meeting specifications. And that's, of course, what we use capability for. So an assumption for capability analysis is that if you're going to tell me how capable your process is, there's an assumption that that process is somewhat stable over time. Because if it's not really, I can't really rely on that. So it was very common for people to look at control charts and assess stability before calculating capability. And there are a lot of applications across industry for control charts. Within manufacturing, again, we'll talk about real-time SPC, probably the most common area that we see applications of control charts, but you can really see them anywhere across any areas. Like I said, any area that has a process or collects data, and that process behaves a certain way over time, control charts are a great candidate to consider adding in to your tool set. So like I said, when I'm manufacturing parts, it's great to be able to monitor temperatures over time, viscosities over time, but also delivery times. If I'm looking at the wait time for a customer in a line for a coffee, I can track those things over time to see when do I have a process that's reliable, stability from a stable standpoint. When might I need to add resources or do some other things to make sure that I maintain that time? Like I said, within business analytics, we see users adding these control charts into dashboards to be able to get a good sense of the stability of a process over time, in addition to all the other metrics that they'll use within BI. So just wanted to mention that it's very common. You might see control charts also referred to as process behavior charts. And that's fine. Process behavior charts, I tend to see this word more in healthcare settings, but that's not across the board. But control charts and process behavior charts are pretty much the same thing. Process behavior charts, I think, is probably a little bit nicer description to describe really what the benefit is and what you're doing with them. So probably why they're coming in. Okay. So there are a lot of types of control charts, and I'm not going to go through all of those. I'm showing you the list just so you have just an awareness that there are many different types of control charts. In my experience, we see the individuals chart the most. Individuals is just plotting on the continuous data side. So when I'm measuring something like a viscosity or a temperature or a time, just plotting those over time without any other considerations. We'll talk about a couple of the other ones here in just a minute. But as if you're just getting started, individuals charts will probably accommodate 90% of the problems you're trying to solve. We also have charts for attributes data. So when you have proportions data, just know the percentage of things that were done, percentage of defectives, the percentage of customers who decided to purchase some product. The proportions chart is probably the most popular on the attribute side to be able to plot those proportions over time. and again, some other things as well. Now, when I say control charts in terms of when we decide what those lines are, those upper and lower control limits on a control chart, those are determined by the normal variation, what's normal to see for a process. The way we estimate what that inherent variation is in a process is using something called rational subgroups. Now, rational subgroups, the idea behind it is that you want to collect data so you want to collect information to really estimate what the true variation is of the process. So removing all of the external things that might be affecting that process, if you just looked at the natural variation of, like I said, something you're manufacturing, you just really want to know how much variation is normal to see. So if I measure, if I make something, two things within the same time period, do they vary by 10 units, by 20 units, by 1 unit? What is that natural variation? And that's really the idea of subgrouping. Now, if I go back to my control chart list, the individuals chart is just the eye chart where I'm assuming a subgroup size of 1, where I'm really not sure, and it just depends on the process, where I just take a single observation every time I sample, and that's fine. That's a very common, I tend to see that more often than not. Mean range charts, this is when you have relatively small subgroup sizes, usually around 5, between 5 to 9. The S chart, standard deviation, where we're estimating this variation using more samples. The important part to know about that is that I really want to estimate that variation to be able to understand what is the common cause variation and what's special cause. So let's talk about that. So common cause variation. So this is the variation just naturally inherent into the process. It's just if I did something over and over and over again, what's that natural bouncing of the process? And this is like I said, this is what the control chart's trying to capture. When do I have the natural variation that's just inherent to my process? And when do I see special cause variation? So special cause is unusual sources or some assignable cause that we can say, okay, the numbers changed. What's the reason for that? How can we go back and understand what affected this? Is this a new supplier went into the mix? Is there something in the manufacturing process where we had to shut down for a little while so the product started to cool? Was there a new worker in the process, at the coffee shop where suddenly it took a little bit longer because we were doing training for a few days? These are these special causes of variation that we try to understand the reasons for, so we can either accommodate them. Sometimes special cause is good, sometimes special cause is bad. But the control charts will allow us to identify these special cause, which really allows us to take that next step of trying to dig in and understand what's going on in that process. Now, when we look at a control chart, we have what we call tests for special causes. And what the tests for special causes are these tests to tell you, okay, when do you say that there's assignable cause on a process? The most common test and the most popular one is test 1. And I just took this snapshot out of Minitab Help. Minitab Help, if you Google, Minitab control charts, you'll get there. Our support pages have a tremendous amount of information about control charts and rational subgroups and all the different types of charts. So if there's a specific chart in that list I showed you before and you're interested in, you can search Minitab Help, and that's free online. So these are a sample of these tests. These are called the Western Electric tests, the Nelson rules, depending on the order and some slight tweaks. But basically, test 1 is basically 1 point more than 3 sigmas from the center line. So a point that's 3 sigmas away is far enough away to say that this is something that you should take a look at. There's also these other tests, 9 points in a row on the same side of the center line, which would indicate some kind of clumping where suddenly the process is staying above or below the average longer than you'd expect. But again, all these tests are things that you can decide to add onto your control charts to make them more powerful to identify potential special cause. Like I said, it's a balance, and we can certainly talk about that if you have questions. So let's talk about some of the use cases for control charts. So the most popular use case for control charts that we've seen in just regular usage among process engineers, people that are in continuous improvement and operation excellence, is using the charts to investigate and analyze a process. So this is the kind of what I think about as self-service analytics, where I'm using something like Minitab statistical software. I'm creating my control chart as part of my analysis, and I'm looking at this in my application, kind of doing the analysis myself, not really using the control chart as this ongoing, consistent monitoring where every time data's coming in, I'm updating the chart and looking at it. This might be more of a bulk. As values come in, I recreate that chart and I'm looking at it. And because I'm usually analyzing this data myself or team, we're not getting things like alerts and all the other things that I might want in a bigger system. But control charts have classically been very useful as exploratory tools to help us, like I said, assess stability over time. This could be, like I said, as we're getting ready for a capability analysis. This could also be looking at in context of gauge R&R studies, or just looking at a process where we've collected some data, some observational data, and we just want to get a feel for what's happening in terms of the stability. We can easily do that. So here I'm just showing you a picture of Minitab, where a proportions chart, where we can start to investigate to see, as we look at things, to see what's going on. The next place you see control charts, and I'm seeing this pop up more and more, is in dashboards. So as a complement to the business intelligence dashboards, people are adding control charts as another tool in their tool set. And this is smart, because if you're looking at data over time, this is a little bit more powerful than just looking at a time series plot and plotting data over here. So incorporating things like the eye charts or the X bar R charts, depending on what data, how you're collecting it, P charts, these actually complement a business dashboard quite nicely. And we can do these in our Minitab Connect solution. And I'll show you these in just a minute. And of course, the next way is within statistical process control. So perhaps this is the most, I don't want to say well-known, but when people think about control charts or when they say SPC, usually thinking about a manufacturing system, manufacturing process, where the goal is to ensure that quality, making sure that the process is efficient, as effective as possible, and those control charts are able to monitor incoming product that either maybe I'm hand entering some information, maybe I'm automatically hooking up to my databases as they're entering in. Now the control charts, if you think about the needs of the control charts from a system like this versus a system like where I'm just analyzing the data myself, say in Minitab statistical software, very different needs. So here from the manufacturing floor, we need to make it easy for operators to enter data, be able to put data in. I need to be able to have manual entry, but I also need automatic data entry. More of us than ever have systems where the data is automatically being collected and putting into some system, and I want to be able to leverage that data and be able to use that to be able to track the quality over time of that system. The other component of a real-time SPC system is that I want the monitoring. I need to be able to monitor in real time. If I want to be on the floor and looking at the screen to look at as data's coming in, that's great. But if I'm not, if I'm in another manufacturing plant or I'm in the office, I still want to receive those notifications and alerts, and I want to be able to control those alerts. So I might want to know for one process, I might want to know when it's out of specification. Specification being, outside the limits of, how the product is supposed to perform. I also want to get alerts on out of control. Out of control, of course, in the context of with talking about control charts, when that process becomes unstable, when I start to see values that tells me that there's some assignable cause, there's some special cause affecting that process that would, tell me that something's going on. And I need to be able to apply that monitoring across different products, processes, stations, manufacturing locations. Like I said, I need a more robust solution than just a simple control chart, in an analysis tool. And finally, the reporting. I need to be able to look at capability. So while control charts are great and tell me about stability, I also care sometimes more about how well I'm meeting specification. So I need those capability reports in conjunction with this, and I also need to be able to roll up that system as appropriate. So being able to get that big picture view of where are my problem areas, which parts of the manufacturing process are good, which parts of the manufacturing process are at risk or need some more attention from the engineers. And finally, I think about that next generation SPC. What's next? Because real-time SPC, there's been a lot of systems for years that have done this sort of thing, monitoring a process. And yes, the technology's changed where, now we're seeing more cloud systems than ever. But at the end of the day, if you have a process and the quality is not good, you've got to decide what to do about that. And what to do classically about that for engineers is, brainstorm, start to troubleshoot and say, okay, what's going on? My process is not capable. Process isn't stable. What is it about that process that's going on over time? So you start brainstorming. Maybe you're using some fishbone diagrams. We have solutions that help you with that. You start collecting data on that process. You decide some inputs that you need to measure. That's where we start to think about how we're going to solve these problems. So again, I don't think it's uncommon for real-time SPC systems to monitor not only just the responses, so maybe I'm measuring viscosity of a product with color, but also measuring the inputs, the pressure, the temperature, all the other settings, the factors that are involved in that process that would help me predict what's going to happen, maybe at the end of my process at the line. In that case, you want to start thinking about how you're going to incorporate other tools. And this is where tools like predictive analytics can really help the engineers solve these problems. So if I can keep track of the input variables and monitor those, as well as the output variables and monitor those, when I do identify a problem in my process, I want that to be a relatively painless experience to be able to start doing my root cause investigation to try to understand tying the effect of those inputs to the output. Can I identify a reason or some factor settings or some interaction between factors that would tell me that these factors would affect my response? And this is what I think of as next generation real-time SPC, is being able to not only have process monitoring and alerts and all those things that are must-have, but also being able to incorporate with an analytics tool that will allow me to dig in and do those predictive analytics easily and having that data ready. So we'll take a look at this in just a second. But a next generation tool would have things like, being able to set up a process and keep track of that. But also thinking about those from not only just the outputs, but also those inputs, so the process measures, as well as the output measures. And by thinking about that collection and thinking about that and having that configured up front, what's important about that is that allows me to do a couple things. One is that when I do have a problem on that process, I can start to investigate what's happening, and I can start applying some predictive analytics to that. So being able to fit some models and understand what are those relationships between the response and my, and my inputs, and also be able to start to identify settings, areas where I do want to operate, areas that I want to avoid. So really, like I said, trying to get to root cause as fast as possible is really the goal. I'm going to switch over. I'm going to share my screen and show you now some of these things that I was just talking about, so I can show you within an application what this is. So let me go over here on, I'm going to share my screen, and I'm going to give it a second because I'm hoping that you see that. Okay, so here, so if we go back to those things, I started off by talking about self-service analytics. So here what I'm showing you is Minitab Cloud. Minitab is the statistical software application where I'm using it to analyze data. And usually if you think about the nature of the work, it's usually an individual who's analyzing data themselves, doing some investigation, and then sharing those results with other people. But there's usually more of a, I don't say thoughtful analysis, but it is where I'm doing things, I'm trying things, I'm looking to see, what makes sense, what works. Maybe I'm looking at a bunch of graphs first. But here's where, like I said, when we think about control charts within Minitab, I'm analyzing the data. I'm using the control charts myself, deciding how the limits should be set, investigating, the configuration of that chart. Now within Minitab Connect, which is our dashboarding solution, this is where I would use those control charts in, like I said, more of a BI, business intelligence setting, or just a dashboard type setting where as part of a bigger dashboard, I can incorporate a control chart in there to really understand what's happening for certain metrics over time. And like I said, the different types of charts just depends on what it is you're monitoring, but that allows me to dig in and investigate and take a look at, some ranges of data. And like I said, just like any other graphical or visual that you see within BI, control charts are a nice addition with a little bit more power behind them than maybe some of the traditional just time series plots. Now, finally, I want to switch over to the real-time SPC system. So a real-time SPC system, like I said, you have different needs. So we're still using control charts. So I guess my point of this webinar is that we see control charts in use in a lot of different places. And while they're all beneficial, so they have different needs in terms of what kind of tools or what kind of aspects around them that you need. So for within real-time SPC, there's a couple needs. One is I need to be able to get data into the system. Now that could be via an automatic collection. So we actually can push data in via different connectors, getting data out of the database and automatically populate these tools. We can also accommodate operators who are manually entering that information. So you can see here, I'm just looking at an operator dashboard where the operator can see when their next collection is due, and they can start that collection. So I'll come in here and just show you a simple, I have an operator where I'm coming and entering some data. I can come in and enter 2 values and make it very simple. The operator doesn't have to do anything else other than enter that information. Now, if I go into more of a supervisor view, where I want to be able to see all the processes that are going on and be able to identify that, but also see the view of the dashboard, to see those control charts over time. That's something that, is important, like I said, either via manual collection or automatic collection. And within an operator's needs, I do have a need to suddenly, start putting things like notes on observations. So this is more of I don't say team effort, but it's a bigger process where you have operators collecting data or monitoring a process. You have supervisors that are monitoring them. You have engineers who are in the mix, either keeping a close eye on processes or just really want to know when something's going on. So it's very important that we are able to add notes and communications in addition to alerts on a process. In addition to the operations, the engineers need to have that visibility into all the processes that they're responsible for. And by having that visibility into all those processes, it really makes it just simple to be able to not only, like I said, see what's happening, but just have that visibility across that range. So if I look at, a specific process here, I'm going to look at a full view of my data. So here I'm just looking at a process, the data from the year for a specific process within a station of a process, and I can look at things like the control chart. So here I'm using my control charts, looking at a little bit different view of that. And one thing that you have to think about with control charts is that, like I said, setting those limits and really how much data are you using for control charts. So this is where this is a little different than, say, using control charts in Minitab, where you need to decide, how are you setting those limits? How much data, how far back do you go with the data? And when do you decide that, okay, these are the limits and we're going to use these numbers to lock the limits and kind of keep running? There's a lot of tools within this system to accommodate that sort of thing. When you do make some changes to limits, either because there's been a process change or something that about has changed, you might recalculate the limits at that point. in which case you want the system to update and calculate those limits accordingly. And likewise, for the engineers, they have a need to not only see control charts, but they also need to be able to access things like capability analysis. So they probably need to report that capability up through their system or up through customers. And you want that very easily, accessible to be able to see that information and also be able to share that information through. The other piece of that system, now thinking about predictive analytics and what happens when my quality is not great, is this ability to be able to move that information right into Minitab. So if I show you the setup for this system, let me go in here. So in terms of setting up for a system, let me come in here. I can do things like I said, having my process measures, my output measures. For this one, I'll show you this one as well. Yeah. So this is where I think this differentiates a little bit from traditional real-time SPC systems. So yes, other systems would allow you to measure the inputs and the outputs together, and that's great. And you should be thinking about that. But then what you need to do is you need to be able to leverage and utilize that information, because trying to do some kind of univariate analysis where I'm analyzing each one of these things separately isn't sometimes the best, most effective, or not the fastest way to get to where you want to go. So if I go back over to that view of the data that I had before, what I'd like to do is, like I said, I have this data that I'm collecting, and I might be collecting X's and Y's, inputs, the process data and the response data. But I want to be able to put that data and open it into a system where I can analyze that a little more carefully. So you can see here with one click, I can just click on Minitab and open that file, and then I can just open that file directly into Minitab. So get there. And what this does is allows this data set to come down, which I apologize. Let me just quickly log into this. But what I'm doing here is getting into the system. So I'm just logging in and authenticating. Yes. Here at Minitab, we have a lot of security. Let me get in. Okay. All right. Well, that's logging in. Let me go back over here for a second. So when I'm taking this data, update. As I'm taking this data through, what I'm doing is deciding what range of data I want to take a look at. And you can see I can set this up for all my stations that I've done where I've collected this information from, or I can actually do it for a specific station. So if I've identified a problematic station, I can bring that in here. So let me go over here. Okay. So if I take a look at this data really quickly, it looks messy, looks like a bunch of stuff. But the point is that when you identify, you said, you've got your data collected, your X's and Y's, but then you need them to be in the right format. And this is something that many of you might be trying to do this today. It's probably painful. It probably takes a lot of time to do that, and it's probably unnecessary. What I want to do is you want to collect your data so it's kind of, like I said, lined up and organized so that I can start to look at relationships between my inputs and my outputs. And again, here I am back in Minitab, which is kind of where we started the webinar, where we said, I might be looking at control charts within Minitab for an analysis. But it's somewhat circular, where if I get to the point where I need to understand, hey, how are these variables related? Having this information all in the same, in a nice, clean format that's ready to go means that when I do identify a problem, I can get right into my analysis and not spend any time having to clean that data and get that ready. Which means I can start looking at analyses, start looking at some graphical views of what's happening on my process to start to dig into that. So when I say next generation SPC, it's really SPC with more predictive analytics. And I do think those predictive analytics tools are tremendously powerful, but you need to be able to use them. And in order to use them, you have to have the data not only collected, but then in the format that you need. Because trying to line up data that was collected in disparate areas and then trying to match it up is painful. I know because I used to do it quite a bit. Let me go back over and let's, before we go to Q&A, so think about, I see some great questions in here. We'll get to those in just a second. So this is what we, Minitab, we refer to this as solutions analytics, and it's just our approach to how we provide software and services. So I see there's a lot of good questions about, setup and how do you configure and things like that. Minitab has this, and again, depending on which area where you're using control charts, Minitab is very easy to configure and set up. Connect, you might be looking, for some assistance on just what's the best way to configure, the elements in the dashboard. And obviously real-time SPC, making sure that it's hooked up to the data sources that it needs, making sure that the operators that you're setting it up through the way you want your operators to collect that data and engineers to see it. But with our solutions, we really think about how to solve problems and helping the customer with that. So with that, I'm going to go to Q&A, and I see we've got a lot of great questions for this. So one of the questions was, how do we ensure the security of the system into the cloud? That's a great question. We do have a lot of information about the security. We use Azure as our cloud provider, and there's a lot of benefit to leveraging the Microsoft system for that, but we can certainly give you more information. Okay. So one of the questions, another great question was, the SPC charts, are they automatically updated with the progress of production in real time? Man, that's a great question, and the answer is yes. In a real-time SPC system, they would have to be, yes, as the new data is coming in, I automatically want that control chart updated. When you're using it with something like Minitab, just within Minitab statistical software, you can set the graphs to automatically update, but that's usually not exact. You can set them to automatically update, but that's more of a, if you want that, it's not assumed. Where something like control charts in a dashboard or in a real-time SPC system, I can't imagine that you'd want the control chart to not update. You would want those control charts to always update as fresh data comes in. And of course, like I said, you need to be able to send off those alerts. So I need to get either my text or an email alerting me or my team that something's going on in that process. Some great questions about when you have automatic data collection, what kind of communication protocol do you need? We have information about that if you reach out directly. There's so many different types that it's usually easier to answer a specific question, but we have a whole team that works on connections. So one of the questions was, is it better to use a control chart or a run chart when data points, when you have more than 16 data points? Both of those tools are effective tools. The control chart tends to be a little bit more powerful to identify any kind of trends or patterns that are going in there, but a run chart is also a nice tool. One of the other questions, great question, was does the real-time SPC incorporate an out-of-control action plan when a process has assignable causes? Yes, the answer is yes. When an operator enters a value that is out of the range that you specify, they'll immediately be presented an area where they could put an assignable cause if they know, and they can also then select the appropriate corrective action. Now, of course, there's times where we don't know the assignable cause, which that would kick off an investigation via, maybe the process engineer would receive an alert about that and be able to put that in. But yes, being able to do that and collect those assignable causes is important. Also, being able to collect those assignable causes over time. Because if you think about, if you have a problematic process, you want to be able to see, over the past, say 6 months, I want to see all the assignable causes that the operators logged for me. So I can really understand, Pareto to understand where to get started on that. That's a great question. One of the questions was, if we use moving average charts, what limits should we use? Now remember, we don't want to confuse control limits versus specification limits. And that's a great question. Control limits are what the control chart would generate. So based on the variation, we use a subgroup size 1, and in that case, the moving range is used to estimate the variation. So just looking at the variation of the observation just next to it. But there's some formulas that we're not going to get into in the webinar, but where we do that calculation to estimate that value. So we could do that. And another question, that's a great question, is how do we choose the reference time period where we assume the process has acceptable variation? What criteria? Usually what the engineers are looking for is just a process that's been relatively stable for a period of time that's reasonable to their process. It depends on the pace and the rate of what you're generating in terms of data. But once you identify that the process seems fairly stable, that's usually when we lock those limits and say, okay, use these parameters to estimate the control charts at this point. And that's something that is very nice to do. And actually, I can do that within our system. So, okay. I don't know. I won't be able to get to all the questions because I started that we're going a little over time. But another question about how long to maintain the process before fixing the control limits. That really is, like I said, case by case. But as soon as you, it's usually better answered by the person who understands that process. But my advice would be, if there's a period of time that seems reasonable. So if I'm looking at a process where I'm making things every minute and it's been running pretty well for the past few hours, maybe a couple of days, I'd lock the limits on that. But it really depends on the nature of that process. Is it a startup where it's just starting and it's still not a stable process, or is this a process that's been running, for years and, it's one that's we know exactly what's going on. We understand usually the reasons for the special cause, and then we can lock those limits and be able to just let that process run and set that. It's very easy to change those limits and update those limits within the real-time SPC system, which I think is something that you want to do. It's also, you can also change those limits in any of the areas on the Connect dashboards and also within Minitab itself. And then there's a question, is there a connection with CART? Yeah, I think CART is one of those predictive analytic tools. When we think about that, being able to leverage those inputs, the process variables with the output, there are a lot of different predictive analytics tools within Minitab that we can use. CART, the classification regression trees, is certainly one of them. TreeNet, the gradient boosted trees, is pretty powerful when you have a lot of data and maybe some messy interactions. But even the classical regression tools sometimes can be great and really be able to dig in and understand what's happening. And I should mention that I've been talking about continuous responses or continuous measurements. I can also do the same type of work for defects, where I'm just measuring a defective and saying, oh, part is good or bad, and still trying to dig into that information as well. Okay. So to wrap up, we have like I said, we have control charts in a lot of different places. So self-service, when you're analyzing data in Minitab and you're looking at the charts there, very nice. And maybe you've been using charts in Minitab where you are updating them regularly with either a Minitab macro or setting them up. And if that works out, that's great. But if you're trying to do things where, like I said, maybe you want to have a dashboard where the purpose of the control chart is something that you want to share with a lot of people, you want a lot of eyes on it, it's part of maybe incorporating it into business intelligence to make that better experience, then we can put those control charts up in a dashboard. And finally, in the manufacturing setting, manufacturing framework, when I have a system where I need robust, I need to be able to set up that system, I need to modify that system as needed, I need to have operators with an easy-to-use system to be able to put data in, I need connections to data that's constantly being updated. I also need, like I said, I need alerts to send off to whoever I needed to send it to, and I need roll-up to see overall which processes are good or which ones are problematic. Then you're looking at more of the real-time SPC system, being able to take that data collected in this thoughtful way and immediately be able to do some further exploration with some predictive analytics is important, and being able to have that set up. Because like I said, if those of you are trying to do this work today, if you're trying to manually move a lot of information, it's probably a lot of work and probably more painful than it has to be. So in that case, real-time SPC is something that you certainly want to get more information on. On our website, minitab.com, you can access information about all the products and things that I've showed today. And if I didn't get to your question, I will get to it and send you an email separately. But I want to thank everyone for taking the time with Andrea and I today, and have a great day.